Hey students, what's going on? Let's talk about 8-7, factoring special cases, aka we're doing the reverse of section 8.4. So if you remember section 8.4, this guy right here, was when you were squaring a binomial. Remember there was a shortcut. You could just square the left, square the right, and put a double product in the middle. So what we're doing today is we're going to spot these special cases, and then we're going to turn them back into a binomial squared. Okay, so look for something squared at the beginning, something squared at the end, and make sure you have a double combo of those two things in the middle. And then also don't forget the difference of two squares pattern. Okay, literally you look for a difference of two squares. So let's undo section 8.4. Okay, what are we doing? Perfect squares. Okay, if I told you this perfect square had an area of 36, you, a smart student, would know that the side lengths would have to be 6 and 6. Okay, that's it. All right. What if it was a trinomial? Well, this is one of those perfect square, hence a square, perfect square trinomials. Okay, so it looks like it starts with a square and it ends with a square. Okay, so I'm guessing it used to be x plus 9 by x plus 9. Now let's double check to make sure it's right, because this middle number could throw you off. So let's make a polybox really quick. If this truly was x and 9 times x and 9, there's our x squared. There's one 9x, there's another 9x, and then there's the 81, okay? So 18 is indeed the double combo of 9 and x. Double combo. What do you mean double combo? There's always going to be two of them in a perfect square. That's all we're doing. That's all we're doing. We're looking at things like this. Now, here's going to be the fun question I'm going to have you do today. Okay? What would x have to be if you wanted these two squares to be equal? Okay, well, if you want the squares to be equal, then you want their sides to be equal. So this is kind of like a bonus question that will be on your Schoology questions. So all you do, friends, is you just set the side length of this guy equal to the side length of that guy. And that's a good old-fashioned one-step equation. So minus 9, x would have to be a -3 for these two to be equal. Okay, so x would have to be -3. 6 times 6 is 36. That means if you plugged in a -3, you should get 36. We don't have time for it, but that should lead to the right answer. You plug in a -3, you'd have, oh, -3 plus 9 is a 6. Here's 6. 6 times 6, hey, it's 36 again. Okay, so there's going to be questions like that. If you want two squares to be equal, guess what? Find their sides, set their sides equal to each other, and then you can do math. Okay, so this is the one that I just had. Look for something squared at the front, something squared at the end. So kind of a big dead giveaway is probably going to be x plus 9 squared again. If not, make a polybox, prove me wrong. Okay, something squared at the front, something squared at the end. I'm going to guess this is x plus 5 squared. 5 times x is 5x, doubled, yep, double combo. So here we go, whether we go. Again, all I'm doing is I'm just reversing the things I did in section 8.4. Okay, something squared. Uh-oh. 18. I don't think 18 is one of those special squares. Okay, not a special square. Could we do magic numbers maybe? Maybe this is a bad one, hiding in plain sight. They're the things that multiply to 18 and add to a -8. I don't think so. How can you make an 18? Let's see, you can do 1 times 18. That's not going to add to a -8. You can do 2 times 9. That's not going to add to a -8. You can do 3 times 6. That's, yeah, so this one's not factorable, friends. Okay, ouch. If this had been something else, maybe like a 16. Ooh, what if it was x squared minus 8x plus 16? Okay, something square, something square. It was probably going to be x minus 4 squared. Okay. Again, how are you doing this so quick? Mental math, friends. Double combo in the middle, square the left, square the right, double combo in the middle. I'm just reversing the things I did in lesson 8.4. Let me prove it with a polybox here really quick. X, -4, x, -4, x squared minus 1, 4x, minus another 4x, and then a positive 16. Combined together would be a -8x, x squared minus 8x plus 16. Okay, so the only thing that really transfers, friends, is the positive and negatives. And we kind of already talked about that. You should have already seen that pattern. Okay. If it's a plus, everything's positive. But if it's a minus, then your binomial was a negative. So hopefully you see that connection. Minus, 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 minus. You can kind of see the idea there. Okay. Stay on your toes, friends. Okay, this one. Something squared, something squared. Ooh, a minus. I'm guessing it was x minus 6 squared. That minus sign is going to go into the binomial. That minus sign is going to go into the binomial. This plus one, this plus one. If the second thing is ever negative, friends, if the second thing is ever negative, like if it ever is a minus something at the end, no, that doesn't work. Not going to be factorable. Okay, so don't even worry about it. All right, so there you go. That is undoing section 8.4. Perfect square. Perfect squares. Okay, so you could also start with, besides a plain x squared, all of mine are kind of basic here, you could also start with these. Okay, if any of your binomials or trinomials, excuse me, any of them, if your binomials or trinomials start with these, this is what it used to be. All the x squareds used to be an x times an x. 4x squareds used to be a 2x. Okay, 9x squareds used to be 3x's. Okay, so this nice little list right here might help you with some of the tougher questions. Okay, they don't all start with an x squared, so stay on your toes. Quick example of that. Let's say you had a, I don't know, how about a, how about a 4? We'll do a 4x squared. Say we had a 4x squared. We ended with a 25. My mental math tells me we'd have a 20x in the middle. Okay? Okay. What did this used to be? Well, I'm guessing this used to be something squared, plus. What did u used to be? Well, it used to be a 2x times itself. U used to be a 5 times itself. Now, where'd you get this 20 from, Mr. K? Double combo. 5 times 2x in my head, I knew was 10x. Doubled it to get the middle. So this guy right here used to be one of those. Okay, so look for something squared, ending with something squared, and then hopefully you have the double combo in the middle. All right.